Alright, so we were asked to do two things here, make a table of values and sketch the curves. So let's do that first, number one. Now, as we look at this, we're just going to pick values of t and then plug it in and find out what we get here. But if we look at this square root here, we hopefully realize that t has to be greater than or equal to 1 to keep that real. So let's start with 1. And if we plug 1 in there, we would get 0 for x. And if we plug 1 in here, we would get 3 for y. Now we want to choose carefully to make this nicer for us. So I'm looking at the square root here, so I'm thinking what would be another good number to plug in for t? What would be a good number to plug in for t? Anybody want to share? 5 would be a good number. There's a number before that we could use though. I'm going to put 5 over here. That's a good choice. Okay. 2. Yeah, 2 would be a good choice also. Both those would be good choices. So 2 is a good choice because 2 minus 1 is 1 and the square root of 1 is 1. So that's good. And then we can plug 2 in over here and we get 4. And 5 was also a good choice because 5 minus 1 is 4 and the square root of 4 is 2. And 5 plus 2 is 7. And let's just do one more. I don't know if that'll even fit. I don't think that'll fit on the graph, but what would be the next good number? Probably. $10, yeah, good. Alright, so 10 minus 1 is 9, the square root of 9 is 3. And if we plug in 10 here, that'll be 12. So I don't even think that's going to be on the graph, but so this is something that's normally done in pre-calculus. So that was a couple years ago, but parametric equations. So now we're just going to plot these points, but the thing about parametric equations is they do have a direction, so we need to think about where we're starting from. Kind of hard to see the x and y axis on here, for me anyway, but there's the origin. I'm going to put the origin on there just so I can see it better. So 0, 3 is right here. That's going to be our starting point. And then we're going to go to 1, 4. And then 2, 7, which is right here. And then, yeah, 3, 12 is going to be off the graph. So what we do to show direction is we usually put arrows on there. So I guess that arrow I would darken in because that's the graph, but the arrows that we put on it to show the direction are usually not colored in. So I could put one more up here maybe. So that's showing that it's going that way. Alright. Then eliminate the parameter. Now usually the main way to eliminate the parameter is to solve for t and then to substitute. And normally when we're graphing something, we kind of like it to be y equals. So I'm actually going to solve this for t and then substitute it in there. So if we take x equals the square root of t minus 1 and we square both sides, we get x squared equals t minus 1. And then if we add 1 to the other side, we're going to get t equals x squared plus 1. So now we can substitute that in for t. Now in this case, nothing's happening to t. It's just t, so it's not a big deal. So this would look like here. We just substituted in for t. And so it was kind of silly on this one because we could have done that in our head probably and just got directly to here. So that's eliminating the parameter. We eliminated the parameter t. Okay, so you see how it's pretty simple, right? Remember that a little bit from pre-calc, maybe? I don't know if that was... Oh yeah, you guys had pre-calc the whole year because I was thinking last year, but you guys had me last year. So, all right, two more. So this one, this one told us to go from -2 to 3, so it's not going to have an arrowhead on the end. It's going to have points on the end, but it still will have a direction. It'll still have those arrows on it. So if we plug in negative, so you guys can just do this really quickly. I don't think you need to wait for me. Just plug them in, get the points. So 4 minus 3 is 1, and then -4. So I'm just going to plug these in. So you should just do that on your own and check to see if we have the same thing. I'm just plugging them in. And 2, and that's 1, and 4, and finally it's going to be 6 and 6. Okay, so we want to start plotting those points at the beginning, so that's going, gosh, this is just going to darken in the x and the y-axis. Oh, that didn't do much, did it? Alright. 1, 1, 2, 3, 4. And then -2, -2. And then -3, 0. And then -2, +2. And then 1, 4. And then 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's going to end there because of this. So we don't want to put an arrow on that. Now we started here. So hopefully we can all see this is basically a parabola. That was kind of not good there, but and it's going in this direction. So I'm going to put these arrows on the graph. Alright. And now we want to eliminate the parameter again. So this is a sideways parabola. Normally with a sideways parabola we have x equals. So if we solve this, so as far as deciding like what to substitute out, if it's on a free response it won't matter because unless they tell you, they'll accept either one. If it's multiple choice, you should be able to tell from the answers if they got y by itself or if they got x by itself or whatever. So now we can just substitute that in for t. So that's going to be y over 2 squared minus 3, which is 1/4 y squared minus 3. So just normally if we're looking at a sideways parabola, it would be x equals. This last one's a little bit different because it's got a trig function in it, so the first part's kind of the same. We have to decide what we're going to choose to plug in here. So, excuse me. I want to choose stuff that's going to come out nice, which would basically be the quadrantal angles, 0, 90, 270, stuff like that. So pi over 2, pi, 3 pi over 2, and 2 pi. Otherwise we're going to get radicals, and I don't want to have to try to approximate those on a graph. So hopefully this will be enough to let us know what we need to graph here. So we plug in 0 for cosine. A cosine of 0 is 1, so we're going to have 3 plus 2, which is 5. And if we plug 0 in for sine, the sine of 0 is 0, so that's going to be -1. Now if we plug in pi over 2, the cosine of pi over 2 is 0, so that's gone, so that's just 3. We're almost done here. And if we plug in pi over 2 here, that's 1, so that's 3, so -1 plus 3 is 2. Okay, moving right along, cosine of pi is -1, so that would make this -2 plus 3, so that's 1. And sine of pi is 0, and that's going to be -1. 270, cosine of 270 is 0. Cosine of 270 is 0, so that's going to be 3. And the sine of 270 is -1, so that's going to be -4. Is there any question on where I'm getting those coordinates? Okay. And so 2 pi, so cosine of 2 pi, we're back to 1, so that's 5, and -1. Okay, so 5, -1. I really wish that axis was darker. Okay, 1, 2, 3, 4, 5, -1. Okay, then 3, +2. Just putting the origin there, so is that 1, 2, 3, 1, 2, and then 1, -1, and then 3, 1, 2, 3, 4. Now, if we go in order, so we went from here to here, so well, I can graph it first. So hopefully you can kind of tell that looks like an ellipse, kind of like a it's not horrible, but kind of like an egg or an oval or something. So think about where we went. We started at 5, -1, and we went up here. So we need to put some arrows on this to show which way this is going. Alright, now this one's a little bit different because it's a trig function. So what we want to do here is we have sine and cosine, and so the formula that we like with sine and cosine is sine squared t plus cosine squared t equals 1. So that's a little bit different. If we have sines and cosines, there's a good chance we want to use this formula over here. So this is one way to think about it. There's another way to think about it, but let's just do this for now. You can look in your book and see if it has any other suggestions as well. So here I'm going to take x minus 3 and divide by 2. That'll be cosine of t. And over here, if we add 1 to both sides and divide by 3, that's going to be the sine of t. So if we substitute those in, and normally we put the x first, so I'm going to do that first. So if we square this, that's going to be x minus 3 squared over 4, okay, plus, and now if we square the y, we're going to have y plus 1 squared over 9, and then we're substituting that in there, so that equals 1. Now, if you've already done the book notes on 9.1 on conic sections, if we have a plus here and these numbers are different, that means it's an ellipse, which we can see from the graph as well. And then the center of the ellipse is the opposite of these coordinates here. So that's going to be 3, -1, which looks like we would have right there. And then underneath here you have the major and the minor axis. So if you square root this, that's 3, and then that means you go up 3 and down 3 from the center. And if you square root this, you get 2, and so you go 2 to the left and 2 to the right. So there's other things we could talk about. So the minor axis is 2 times 2, which is 4. The major axis is 2 times 3, which is 6, which we could count off the graph. But alright, so that pretty much wraps that up. That's just an introduction, so that's to get used to that before we start doing some calculus with parametric equations. So